Hello and welcome everyone. Thank you for joining our webinar, Cracking the Code of PCF and LCA today. We are going to talk about university insights as well as how to convert them into real industry actions. Before we officially start today's webinar, one second. I'm going to quickly give you some general info on what this webinar will look like. The webinar will approximately last 45 minutes. It will be recorded and sent to you afterwards if you want to rewatch it. And yeah, everyone else but the speakers are being muted. So if you have any questions, please put them in the chat. We will have a Q&A session at the very end of the webinar. So yeah, our speakers will answer them later. Taking a quick look at our agenda today. In just a minute, I'm giving you a quick intro on IPOINT in case you're new to us or you need a quick reminder on what it is exactly that we are doing. Then I'm going to hand over to my colleague Sabrina Neugebauer, who will talk about the foundations of LCA, followed by Patrick Lennart, who will speak to us about his experience with university projects and how he's now using that experience for practical application. And after that, Martina Prox will present on PCF and LCA standards by industry initiatives. And yeah, like I said, at the very end, we have some time to answer your questions if you have any. So, like I said, before we dive into today's topics, let me give you a quick introduction to IPOINT Systems. IPOINT is a leading provider of digital solutions for product compliance, sustainability, and circular economy. Our mission is to empower companies to make informed, sustainable decisions across the entire product lifecycle using data-driven, transparent, and efficient tools. One of the key solutions in our portfolio is Umberto, our lifecycle assessment software. Umberto helps companies analyze and optimize environmental impacts, from calculating PCFs to conducting complex system-level LCAs. Some of you might remember IFU Hamburg, which is the original developer of Umberto. But just for explanation, IPOINT and IFU joined forces back in 2017. And with that, they combined deep LCA expertise with innovative technology. And yeah, that synergy is a big part of what we're going to share with you today. And with that, I'm handing over to Sabrina.
Hi, everyone. Welcome to our lecture or to our webinar. I will, for the next 10 minutes approximately, a bit talk about where LCA is coming from and why we are using it in the way we are using it today. Next slide, please. So I brought with me a timeline, if you want so, to a bit elaborate on like where it all started. So I think LCA is there for really some decades. It's almost like, or it's actually 50 years. One of the first studies, or the first studies were always about packaging, but it really hit off when the first oil crisis started. And there something like a green movement started as well. And from that point on, the people were like more concerned about the environment. They were concerned on how we assess the environmental damage we're creating. And from that, also the first impact categories resulted. And then in the 80s, when it really like became severe and it really started that people had concerns about it, the term life cycle assessment evolved. And then there was a lot of work done in the European context, but also in the US context. And first studies were initiated. The first ones were quite often around packaging. Then the first guidelines were published from the SETAC, the Society of Environmental Toxicology and Chemistry. And then in 1997, the first ISO norm was officially launched. And from that point on, life cycle assessment was really a marker for environmental assessment. Next slide, please. And from that moment on, it was really used for very different purposes. So of course, it has an inherent incentive to it that we want to improve our sustainability performance of our products. We want to optimize our product design towards more sustainable, more environmental friendly products. We also want to enhance the awareness towards that goals to mitigate environmental impacts, for example. But of course, from the very first moment, the companies also use it, I mean, rightfully use it for marketing purposes as well, because I mean, do something good and talk about it. So it is always used for marketing. And now with a lot of regulations, especially in the European context, it's also a legislative nature to it. So we have to have environmental reporting of certain kinds. So we need to report on our environmental impacts of certain products, depending on the industries companies are dealing with. And of course, that is also involving decision making, like where a company wants to go, where it wants to improve, and how we want to develop our future products. And with that, we have life cycle assessment, which is a very standardized process. So it's an international standardized process with the ISO norms. We now have I don't know exactly how many times the ISO was updated, but it was quite a lot since 1997. And the goal is unchanged, however. So the goal of a life cycle assessment is still that we want to assess the environmental impacts of a product across its entire life cycle. On the right-hand side, you see the picture there where we orientate on. So we start always from the raw material extraction over material processing, part processing, product use, and end of life. And then we circle back also. And it analyzes the impacts of product, processes, or services. And we want to assess the full scale. So we want to have a holistic picture of all the environmental impacts occurring. Next slide, please. And that is very relevant as we really want to consider the impacts affecting soil, air, and water, because we have a lot of emissions and resource use across all those three. And normally we take into account all the input and output flows over a system. I think you will hear that more from Patrick then later on. And we want to assess all the impacts occurring with our decisions around production of products and services. So that is very relevant, and also consider the different environmental impacts in the different spheres like soil, air, and water. With that said, so we have also a lot of capabilities what LCA can do, but we also have, of course, also limitations. So what LCA can do is we can assess the potential environmental impact of product systems for very different impact categories. So the most common one is probably global warming potential or climate change, which is used very broadly nowadays and has quite a common aspect to it. But also we have, of course, in addition to that, a lot of more environmental impacts like eutrophication, acidification, or also resource use as an impact itself. So there's a lot of impacts, but you always assess the potential environmental impact. You never assess the actual occurring environmental issues. You have more like a snapshot of a system, and you assess what could be happening. You with that also identify the hotspots in your production processes, and with that the optimization potentials, but you never actually predict actual environmental impacts. That is a very, very severe limitation you have to keep in mind, because of course for the later one you can have risk assessments and have it very specific and precise, but you will not do that with lifecycle assessment. But what you can do, and what I think is the great benefit of doing lifecycle assessment, is that you will achieve a very holistic picture of, if you do it like very comprehensively and you assess a lot of different environmental impacts, you will achieve a very holistic picture of your product and what potential harm it can do to the environment, and where you really can turn some wheels to make it better and make it more sustainable. So that is a very great advantage, in my view, of doing environmental assessments. And of course, with that, you can also explore future scenarios. You can see, okay, if I change that material and I replace it by another material, or I switch to a different energy mix, or I switch to a different transportation mode, what good could it do? And you can have like future scenarios and possible changes in your product system and really predict what good could it do in terms of environmental impacts. Here the limitation is more that you limit to environmental assessment only. You of course will not predict with that societal consequences or societal impacts. But I mean, it's good to start with environmental impact, and I think it's a very powerful tool to do that. Next slide, please. And I think that is one topic. It's really to the heart of every practitioner in lifecycle assessment. I always say to our customers that it's all about the data, and it's kind of true, because we have a big ISO standard framework. We have the GHG protocol. We have the ISO 14040 and 44, which Patrick, I think, will also tell a bit more about. We have frameworks like Catena-X in the making. But at the end, it comes really also down to the data. We provide some guidance, we provide some tools for it, but the data you put into your lifecycle assessment is really very essential and crucial. That's why my tip for all practitioners out there is always consider your data quality, make valuable assumptions for your product or product system, use verified secondary data sources, which we also provide with our tools, of course, and follow the iterative process, because you will never get it in a very nice and complete way or comprehensive way on the first shot. It's really like about do it over again, check what you did, check your assumptions, and improve your data quality. And I think with that, I hand over to my colleague, Patrick Leonard, who will tell you about the differentiation between theory and practice and how you really get started with LCA. Thank you very much.
Thank you, Sabrina, for the introduction, and hello, everybody. Next slide, please. My topic is to talk a little bit about the experience that I made during studies and learning the theory of LCA, and then being confronted with the practical implications and the practical facilitation of LCAs or product carbon footprints. Next slide, please. As Sabrina already said, there is a standard. There are multiple standards. Most of them are based on a similar framework or have similar steps. So you have those 4 common steps: target definition, lifecycle inventory, impact analysis and evaluation, and an accompanying evaluation and interpretation. Next slide, please. And one big difference that I saw during studies is that learning about these standards, I was very happy and very excited, because I thought, wow, it's very detailed. You get like a real instruction how to do it step by step, and everything had some rules, and there were like scenarios and what happens, or what should you do if certain circumstances occur. And then taking this knowledge to the practical application, I realized, oh, wait a minute, there's still a lot of space that these standards leave for interpretation, for in the details. It's very unspecific, to be honest. And this was a big surprise to me when I came from this mindset. Okay, there are standards. There's a lot of there's a guideline I can clearly follow, and then being confronted with, okay, in reality, it's a little bit more difficult, was the first big insight that I made. Another big insight also was for me, Sabrina also said it, that what is LCA about? LCA or product carbon footprints are a tool that was designed to make relative comparisons. Now, where it over time developed and even more develops now is to be an absolute comparison for products, because different companies, different producers of goods want to compare their goods with each other. And this brings up the problem that they have to do it in a aligned way so that these values are really comparable. And that's at the moment a really big topic. And I think Martina will show some insights about that's how standardization is going on to get more, or to get closer, or to overcome this problem. Next slide, please. Another thing in the university times, I thought, or my impression was, the better I model a system, the better I model a life cycle, the better the results will be. So the more details I put in, the more accurate I model something, it will be, it will lead to better results. In fact, Sabrina also said it, the important thing, or the crucial thing, is not about the model. It's not about it's not about making the perfect copy of the lifecycle system. The crucial factor is data. And in university, it was or in my experience, it was always easy with the data because we based everything on assumptions, learning the theory. We had like invented examples with invented products, like modeling pizza, like modeling pasta, like modeling some random things, or even disassembling some keyboards or mouses or things, and then taking this as an input, which of course leads to good data, or which kind of skips the issue of data that is really a problem in real life and practice. So the next slide, please. This is a little bit shown or illustrated by this picture, because in reality, you have to deal with multiple stakeholders. You have multiple data sources. Sometimes you have data sources that are not complete or lacking crucial information to relate them to each other. So in theory, the problems of LCA or PCF were completely different than the actual issues that you face in the practical application, because you have to deal with incomplete data. You have to think about, okay, how can I combine this kind of data? So in reality, it's more a data science topic than only pure theory. This was a key insight for me. Next slide, please. Here is a little picture that or a little diagram that shows this, or is only an example for the complexity of the data, how we use it in our tools. So you have to kind of combine the different sources, the kind of different data. You have to relate these different data sets to each other. You have to combine it with the infrastructure, with secondary data, to meet different reporting standards. And that's a lot of data handling in practice. Next slide, please. And I would like to conclude my my insights in the practical versus the theoretical view, that I think this incompleteness or this partially not existing data has to be embraced by the practitioners. And I think that in this regard, it's very close to lean thinking also, because lean thinking is basically handling with these issues of unknown variables and to break it down to iterative approaches, small cycles, starting rough and refining over time. And I think that's a key for being successful or being able to conduct good LCAs or good carbon footprints. This iterative approach, focusing on the relevant, focusing on the big contributors, going into the details where it's necessary, and remaining with assumptions, also sometimes also with worst case assumptions, where like that are not in focus, that are not these big contributors in your system. So to have, as Sabrina said, this full picture, this full comparison. Yeah, that's for me. Thank you for listening, and I hand over to Martina.
Yeah, thank you, Patrick. Yeah, very well connecting to what was already said. Product carbon footprints and LCA standards have been around for quite a while. Next slide, please. And have been used. So it's not that there's not a big experience. So there is product level standards for just global warming potential. There is LCA standards, both also for organizational level and product level. But the fact already that you could see that it's no longer enough to just have a standard on life cycle assessment, and that it has been differentiated so much that it's going into carbon footprinting, or in the standard, I typically say PCF, because in industry standards, it's mostly the abbreviation used PCF. If we are looking at the ISO standards, the carbon footprint of products is the CFP. And the CCF for the corporate carbon footprint. And we have, can you go back again? So we have the situation that we have now multiple standards. Also in the European Commission, we have the product environmental footprint. And what has been mentioned already, this just comparative approach. You do a study, and in the study, you set your framework and you define what you want to compare, specifically on a product level, on product systems, and you make sure that what you compare is comparable, looking at the functional unit, looking at your assumptions that you're taking for both or multiple product systems into account. There, the standards help so that you can do that. And next slide, please. Then we came into the situation of companies making commitments to decarbonize. European Green Deal, decarbonization targets of companies like science-based targets. And that made the Scope 3 corporate carbon footprint. And what you can see, many know that picture. It's from the Greenhouse Gas Protocol, how the product level is linked with the corporate level. And especially corporate carbon footprinting Scope 3.1, which would be represented here by the upstream Scope 3, and major emissions are coming from the materials that you are purchasing. And so companies have committed to that and have put it into their sustainability strategy, into their sustainability report already several years ago, with a decarbonization target by 2040, 2045, even only 2050. But it's now in there. And also investor relations have said, okay, you have committed to that. Now you have to prove that you are on track with your decarbonization. And sometimes the discussion on that in that context, and that refers to the topic of data, is can we do decarbonization targets based on spend-based? So taking amounts of euros that you're purchasing in a certain sector and multiplying that with a CO2 equivalent and coming then to an estimate of an upstream, looking at that part, scope 3 emissions. Can you do that, and can you then prove on how to decarbonize with your specific supply chain? And that created the challenges that led to new industry standards. Next slide, please. And it's not only one, it's several initiatives, several activities from different industries. We have the automotive industry, we have a cross-industry standard from the World Business Council for Sustainable Development, Pathfinder. You could say they were the first. So the first standard was that says, okay, now we need to use ISO 14067 and 40 and 44, ISO 14040 and 44 and 67 as the basis, but then decide, okay, what are now the limitations in terms of room for interpretation to achieve comparable product carbon footprints collected across the supply chain. And that's why they did not only initiate to create standards for the methodology, so a rule book or several rule books have been developed by Catena-X, by PACT, that's World Business Council for Sustainable Development, by Together for Sustainability, and also by the Global Battery Alliance. In addition, at least the three of them have also defined exchange formats, because one important thing that was clear, if you want to prove that you are on track for decarbonization, you have to have supplier-specific information being collected in the supply chain. And so this is all related also to digital infrastructure. Next slide, please. Taking these examples from Catena-X, so the automotive industry today, maybe no longer today, as it has already started, that Catena-X is collecting data in their supply chains, but major activities are still based on secondary data. So an OEM is calculating everything based on secondary data and is basically estimating based on the secondary data what they're buying from tier 1 and tier 2 and creating a product carbon footprint. What has initiated 3 years ago and getting into practice more and more, that they are collecting data from their suppliers, they're requesting this data from their suppliers, and they're requesting also their suppliers to calculate that as much as possible based on primary data. And what we see here, the orange part, is the share of primary data that have been used in the supply chain to calculate that. And the ideal future should be a share of 100%, maybe not 100% realistic, but covering up to 80% of the impact should be in a not too far future based on primary data to be able to prove that decarbonization or reducing carbon footprints in the supply chain really works. Next slide, please. And related to this, in the context of life cycle assessment, we all know critical review is the way of providing trust into a result. And even the standard says, if you want to communicate externally, if this is not only an internal study, you have to do a critical review to be fully ISO compliant. If you think of how critical reviews are done, and even comparative assertions, so you need a panel, it takes another at least weeks, sometimes months, after having finished the study or doing it accompanied. So within the context of product carbon footprints, a verification framework has been established to also share the burden on how to do the verification. And so each company, being part of the supply chain, is being responsible for verifying and accepting from the clients, from the suppliers, a verified product carbon footprint. And it's currently still a bit under discussion if this acceptance of other audits and other verification results is being accepted across all auditors in the context of the public auditing organizations. And up to now, also the way of fully digitizing that or using more digital context on that is still a journey. But the whole framework developed together for Sustainability and Catena-X is set up to enable scaling also of verification and having certified systems of PCF programs internally, so that everyone who is receiving a product carbon footprint from a certain company can trust that this company is able to provide such values and data sets according to a certain standard. Next slide, please. And in relation or in combination, what I was mentioning about the primary data share, also a new digital attribute has been created, and this is the verification share, or also the certification share. So that when you propagate the information, so you're giving a product carbon footprint from tier N to tier 2, from tier 2 to tier 1. Also the information, how much of the product carbon footprint is always related to the impact, has been already verified. And you can imagine the bigger the impact here in the beginning, and if you are in the early stage getting your verification, the better you are being able to have your full product carbon footprint as an OEM verified in your systems, and getting it then also accepted as proof of your decarbonization in the sustainability report. That's only one use case. There's more use cases. Next slide, please. So we at IPOINT, we are totally dedicated to support this working with secondary and primary data in combination. It's absolutely necessary to enable the connection with multiple data sources internally in an organization that you can see here on the left side on top, with secondary data, but also connecting it with your supply chain using the different standards. And the good thing about these digital standards, the data standards, as well as the methodology, at least between these major initiatives, are interoperable and can be combined and are referencing among each other. And so it makes life for a software developer like us comparably easy, that if you are implementing Catena-X, you can also receive data from an initiative of someone who has been calculating according to Together for Sustainability. And so talking about the different use cases, this reporting use case is at the moment, because of the decarbonization commitment, because of the sustainability indicator number 1, global warming potential, it's the most popular one. But we are seeing already today that also within these industry initiatives that started with product carbon footprint, that other topics, so broader life cycle perspective, so a full, let's not say full, looking into the direction of where the EPDs in the construction industry are already that you have selected indicators, getting prepared for the European Commission's product environmental footprint, rolling out that these are becoming more required. So we are expecting, even if now industry is highly focused on carbon footprint, we are expecting that industry is getting back and getting broader to more indicators in the future again, also in preparation for product environmental footprint from the European Commission. And already today, if we look at engineering and design use cases, hardly any company internally only looks at product carbon footprint if they compare one alternative of a future product or a material or a design with another. Typically, internally, more indicators are used than those that are currently shared across the supply chain. And with that, I think we are ready for questions.
I think we had already 2 questions. So the first one was, do you have good guideline learning material about how to model waste management systems, since waste is often treated in a special way? So we do not have a specific guideline on how to treat waste management systems, going beyond the typical guidelines like ISO or the ILCD handbooks, which is very helpful or might be very helpful in this sense. We have, however, under our customers, also customers from the waste and recycling industry, and our expert tool is very capable of modeling specific and very detailed processes occurring along this waste and recycling streams, so that it is possible to model it with our tools, and it's also possible to do it in accordance to the standards and the guidelines. But we do not provide an own guideline for it. But I mean, we could provide you some examples on how to model it appropriately. Martina, you wanted to add, right?
Yeah, I think it's always nice to have examples, but it's very specific on how it has to be done. So I understand that in many contexts you wish to have a best practice, but if we see how different recycling systems have to be modeled depending on which country it's going to. So the complexity to put out something which is very straightforward is just not adequate. So it's really a case-by-case decision. What is the appropriate way of doing that? And so I would probably, if I would think of something that is guidance in that context, asking the right questions, because you cannot provide so many examples of how you can find cases in the world that you have to address. Maybe I'm exaggerating, but that's how is my observation in that context.
Yeah, I mean, for example, you could, we talked about data and different kinds of data, and one important thing for modeling end of life or for modeling like the downstream part of your life cycle is which data is available, what kind of information do you have, what is primary, what is secondary, where do you have to make guesses, which kind of guesses or which kind of abstractions do you have. This all makes the difference. So if you only know, okay, I produce or my product at a certain stage is being disposed, but you don't know where, how, then you can only deal with the statistical averages on global or on regional scale. If you have more details, you can make it more detailed and, for instance, follow single material streams or split it by regions, by country. It really depends on the information that you have available.
Yeah.
Maybe I take the next one about the how long will OEMs continue to accept secondary data. That depends on each OEM. So there is no general. OEMs are saying we are no longer accepting it from that date on. It's specific, and we at IPOINT, we are sometimes involved either on the OEM side or on the supplier side to get ready for that. But it's something which is a B2B negotiated information. And so there's no public available information, to my knowledge, that OEM said secondary data running out until that moment. That's not the case. So at the moment, everyone is, to my observation, expecting to get data and to get transparency on how much of that is primary and how much of that is based on secondary. So the current journey is towards the transparency if and how much is calculated based on primary or secondary data. And everything else to be seen how fast it's going to happen. And the ambitions between OEMs might differ there.
Also, the requirements are very different depending on the OEM, but I agree with what you said, Tina. So
and also coming back to the theory versus practical. I mean, as I said, the practical or the theoretical frameworks gives a certain indications, a certain frame, but there's a lot of space in between, and all these initiatives are trying to kind of fill this space with more specifics, but they cannot like fully fill it. So it's like Martina says, negotiation thing, and yeah, they also face the same theoretical issues as all other LCA practitioners.
Then we have our last question. What is the procedure to become a reviewer for critical review? Martina, probably you will.
I can take it. So I can tell you how it happened to me. I didn't have the plan to become a critical reviewer. So first of all, you need to have experience in a certain technical field, and you need to have experience with LCA. So it didn't happen to me just coming from university, having done only 1 or 2 studies. It happened to me maybe after 5 to 10 years experience in that field. And then a reviewer who had a lot of experience knew me with a certain expertise at that moment in life cycle costing. So because I had worked in the standards and I had done a lot of in the context of life cycle costing, could you help being part of the panel to do that critical review that includes such a costing part? And that brought me into my first experience with being a critical reviewer. And the first experience is like necessary to get the second. So LCA experience and subject matter expertise in a certain area, either the industry part or a certain methodology part, that brings you into the review game. Let's put it like that.
And the requirements by the ISO standard. There's like a standard defining what criteria a reviewer has to fulfill.
ISO 14072 is telling you that. Yeah.
Yeah, so thank you so much. Unfortunately, we've run out of time. So if you have any further questions, please send them to us via mail. I'm going to put also the LinkedIn from our speakers right here. So yeah, feel free to ask them if you have any further questions. Yeah, a big thank you to everyone who participated. Like I said, follow our speakers on LinkedIn. If you're interested in deepening your understanding of LCA, make sure to follow especially Martina on LinkedIn, since she's very active on there. She shares great insights and breaks down complex topics in a very clear way. So yeah, definitely worth a follow. We'd also love to hear from you what topic we should cover in our next webinar. So just let us know. There will be a quick survey at the end of this webinar. And yeah, so that's it for today. Have a wonderful rest of your day. Hopefully we'll see you next time. Bye, everyone.
Thank you for listening.
Bye.
Bye.